Okay, very happy morning to everyone and welcome to the context session 9. And this in this session, I'm going to teach you on the strategic information security. Now, information security gains a lot of importance in today's context, primarily because of the breaches that has been happening and being reported across the globe. But when we talk about information security, let's primarily understand the two words, information and security. The information is the combination of data for a meaningful decision, right? So it is fundamentally how do you go about protecting the data specific to your organization. So what I want you to understand from the last 9 sessions or so is that I've been teaching you on the information technology processes that are required to be handled by a CIO or a CTO. But information technology processes, as I've been teaching to you, they are commencing from the availability management, performance and tuning, right? Storage management, configuration management, change management, right? Network management. These processes are required to be governed only by a CIO or a head of technology. But information security cannot be handled by the same person. And that's a fundamental concept that I want you to understand. Primarily, it is like a software development and quality assurance, or manufacturing and quality control. So the person who does the job himself or herself cannot be given the accountability of validating whether the controls that are available meets the intended requirements to protect the information and data. So that's the very important thing. So information security is a very larger domain. It has got multiple functionalities, which is pretty complicated in nature. But I'm going to teach you the fundamentals that you need to understand on the information security arena so that you would really be able to pursue this quite intensively over a period of time. All right. Fine. Now, strategic security. Strategic security refers to, when I say strategic security, strategy refers to a boardroom exercise, which is primarily for a period of 3 to 5 years. So how do you go about performing a boardroom exercise in order to introduce an organizational structure for information security and ensure that the information which is very specific to your organization is protected by virtue of implementing technology controls. All right. Now, the caution one, the technology controls that are required to protect your organization specific data is very, very unique to your organization. And so it's like finding out what is the cause and symptoms that your organization has got, which could actually be materialized by a threat evangelist and could damage your organization. You need to find out what is the illness that your organization has got and prepare the information security capsule, which is very specific to your organization. So information security is not something which is very common to every organization, though the principles are common, but it is up to you to find out through a formal risk assessment, what are the risk propositions that you have got, which could lead to a threat materializing the gaps that are available, which can result in a situation which is not so warranted for. Okay. That's how an information security will have to be approached. So it is like a meeting a doctor for the illness that you've got, prepare the specific medicine that is required for your illness, specific to your organization, and implement it. Fine. All right. Now we have covered quite a few, right? Starting from availability, performance tuning, production acceptance, change management, problem management, storage management, network management, configuration management, capacity management. Now, these are all perhaps they belong to, except network design is not there. They are all CIO responsibility. or a CTO responsibility or a head of IT responsibility. On the contrary, the one that we are talking about now, strategic security, can never be a part of your CIO. So this has gotten managed by an independent organization. Today, they are being managed at a very, very higher level. That designation is called CISO or CPO altogether, Chief Information Security Officer or Chief Data Privacy Officer. I think that's the role that is expected to handle the entire information security portfolio. All right. Now let's understand some of the basics before we start the discussion in detail. Now I had taught you the OSI architecture in the first session, contact session 1, where the OSI architecture is the modus operandi through which the communication that happens between two entities or two objects or two individuals will have to comply with through these 7 different layers, which is a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Now, the communication is going to go through these 7 different layers, and the recipient of the communication and sender of the communication will physically happen to see the layer 1 physical and layer 7 application. All other layers are hidden. But eventually, since the data has to traverse through these 7 different layers, you have to build the information security at each of the layer. I think that's the fundamental premises with which you need to understand. At every layer, you got to build information security. Okay, I'm not going to rerun what is happening at each layer because you know pretty well, but I'm going to touch upon quickly at each layer, what is that you have to look for in order to build information security? Technology controls. I emphasize technology controls because technology controls are one which invites substantial investment. You'll have to fund for it. All right. In a physical layer, what is that you'll have to look for? You know, physical layer is something where your computer is connected to the network through a formal physical layer, which could be a copper or it could be a fiber optic cable. Now, what is that you'll have to look for if somebody come and do a damage of the copper cable or the fiber optic cable? What happens? The information gets disconnected. So you got to look for, from a security perspective, what are the physical and environmental security controls that are required to protect your physical wires. I think that's how we have to look at it. Fine, all right. Let's move on to the second layer. The data link layer, 2 computers or 2 laptops, when they are connected for communication, the connection within the network happens through the network interface card. Now, the network interface card happens to have a very unique MAC address. The MAC address for every network interface card is so unique as designed by the manufacturer. Okay, fine. Now, what is that you'll have to look for? What is the probability that my laptop MAC address being stolen by somebody who's not a part of the network? That person can steal your MAC address and ensure that your MAC address is wrongly used from elsewhere using a device which is not connected with your network. So you got to look at how do I go about ensuring that my MAC address is completely hidden and secure. That's how we got to look at it from the layer 2. So let's look at layer 3. Layer 3 is what? Layer 3 is network layer in which the communication is transmitted from your internal network, right, to the external. Now, when from internal to external network, when you want the communication to go, what is the uniqueness of your communication? The uniqueness of your communication is the IP address. So the IP address that has been assigned to you is something which is going to be carrying the data, and as and when it starts traveling across. All right, you have a question? Yes, go ahead. I think you raised your hands and what question you've got. Rahul. Rahul, you can't see. I've shared. Okay, now I will reshare it. Right? I've shared. Okay, fine. Right? I'll reshare. I'll reshare. Okay, we'll reshare it now. Okay, is that seeing? Are you seeing it now? Are you seeing it now? Okay, it's my screen now. Fine, it's my screen. All right. Okay, fine. Thank you. So coming back to the networks layer, in the network layer, what is happening? The IP address which is assigned to you is going to carry the entire data, which is going to traverse into the network. But fundamentally, the IP address which is internally assigned to you cannot be understood by the external network. So there is a NATing happens. Translation of your internal IP address into an external recognizable IP address that happens. But what is the security parameter you have to look for? If somebody taps your IP address, then what happens? How do you go about securing the entire IP address and data which carried by the data which is carried by the IP address as well? When it travels to the upper layer, how do I go about protecting the IP address along with the data is what you have to look for. Fine. Then you go to transport layer. In the transport layer, what happens? The data, which is type of data, is required to be travel in a particular channel that's been assigned. The channel could be the port number. So during the data which is carried by the IP address, when they travel into the specific port number, how do you go about protecting the port so that other unauthorized element cannot get into the port? So that's what you have to look for, because in a transport layer, a data can actually travel in the form of a TCP or UDP. There are only two type of a protocol. A TCP is a transmission control protocol in which any data which requires handshaking, when it moves in the upper layer, then those data will take the form of a TCP, typically mail server. UDP is a data when it does not require handshaking, when it travels in the upper layer, then it takes the form of a UDP, right? So how do you go about protecting the port is the question that you got to ask here. Now, in the session layer, when the data has reached the session layer performs two important activities. You got to see one, authentication, other one is authorization. Now, authentication and authorization, which means perhaps you got to look at a person who's seeking the data, a person or who's seeking the permission for sending a data from one person to other person, or one entity to other entity, or one object to other object. You need to look for one. Is that person is unique? Which means every person needs to have a unique ID. The unique ID is very specific to the organization. Two, now how does the person logs into the system? How is the person is seeking the authorization for accessing the data? Which means if the person has been assigned the password, then along with the unique ID and the password, which had been stored earlier for the same person, need to be validated every time whether the person uniqueness which is presented is correct or not. That is called authentication. Authentication happens. Authentication can be multiple level. It can be a single factor authentication, or it could be a two-factor authentication, or it could be three-factor authentication. But the number of layers of authentication could be strengthened based on the sensitivity of the information that is being sought. Okay. And once the authentication is successful, then you would provide the access to transmit the data or access to modify the data. All right, so that's not something which happens at a session layer. And you have to look for it. In a presentation layer, there is a translation happens. You are asking will be converted into a binary 10101010. That's one. Number two, the length of the entire data would be compressed into the specific length, which could be 64 bytes, right? Or it could be 128 bytes, or it could be 256 bytes, or it could be 512 bytes. The length of the data will have a direct proportion to the capability of your entire network. Okay, so it is going to get compressed and then encrypted. You'll have to look at the data is encrypted at this layer so that only sensitive data, not every data is required to be encrypted. That's what you have to look for at a presentation layer. Now the application layer is where the person, sender and receiver will be able to physically see and start designing the information or receiving the information and prepare for response. So this is not something which you'll have to understand the basics of the OSI architecture and what you've got to look for it. Fine. All right. Now, when you come to the question of information security, there are two important principles that everyone has to understand. These two important principles are even today valid. Even after 30 years, it's going to be valid. The principle one, it's called a CIA triad. C refers to confidentiality, I refers to integrity, and A refers to availability. Fine. Now, what is confidentiality? Now, confidentiality is the information or data that is required to be available only for those authorized person shall be made available only to that person. Okay, so that is confidentiality. So when an information is required to be available only for an authorized user, must be available only for that person. If it is known to somebody else, then there is a breach of confidentiality. Now, for example, let's say now each one of us must have been using the internet account, right? If on the last day of a month, predominantly the salary is getting credited. If somebody who is not known to you is calling you and telling you that your account has been credited with about 75,000 rupees, no salary for this month, then the confidentiality, which means the information, the account related information that is required to be known only to you, now has been published to somebody who has been not a part of your system, who has not been authorized. So which means there is a breach of confidentiality. So you need to build the technology controls that are required to protect the confidentiality. That's the C of CIA triad. Now let's look at what is integrity. The integrity refers to the ability of modifying the information only by an authorized stakeholder. Anyone who's not authorized to modify information, when that person has gotten access to modify, then there is a breach of integrity. So integrity can always be protected using an encryption mechanism, but you got to be very clear what data requires integrity to be protected. A data which is required to be available to public does not require technology controls to protect integrity. So integrity predominantly is something where the modification to data is permitted only for an authorized stakeholder and which could perhaps be possible only through an encryption mechanism. But you also need to have, if it's an application, a software application, you got to understand and ensure that the software application has got a ASOD design, okay, aspect-oriented design, in which the activities performed by every login is logged in and they are available using a simpler AI. The fraudulent kind of an activities are being reported and stopped, and that's where integrity could be protected. The third element, A, availability of CIA triad. Actually, availability has been very recently understood by many organizations that it can never be a part of IT. If you look at it, availability is actually not a component of a security, but availability, since availability needs to be looked at it from a very different perspective. When a serious incident happens, let's say there is a outage of the entire power for a period of 2 days, 48 hours, or there is a rain which has poured to the magnitude of 40 centimeter per day, then the people movement is restricted. How do you go about ensuring that even people are taken to a very different location, or people are asked to stay from the location wherever they are in and still have access to information and the business can continue? So availability has later grown as a business continuity management, and the kind of understanding an organization will have to develop for devising the strategic proposition to continue business from an availability perspective is something which needs a lot of finance and money to be invested for. So availability is something which would be an extension of business continuity management. And you have studied availability in the first session itself. How will you ensure that availability of the information is provided? We are going to have an agreed SLA. Okay, not every information is required to be available for 100%. So you're going to look at, what is my agreed SLA and what is the recovery, accepted recovery time objective and accepted recovery point objective. These two, along with SLA, can combinedly make you to understand how much is the business continuity plan that's required. Accordingly, for those information which are sensitive in nature, or which are the information which is required to be accessible every time, always, then you need to look at what is the single point of failure at a system level and at a component level, and introduce resilience. They're going to introduce redundancy. A redundancy mechanism, in order to improve availability, can cost you twice that of the original basic infrastructure that you must have set up. All right. So this is the CIA trial. So what is that you have to look for? You need to understand this logic very clearly in the principle. You got to find out what is the information in your organization requires a confidentiality protection. What is the information that is required in your organization that needs the technology control for protecting the integrity? What is the information that is required to be available for 24/7 every day throughout the week and 365 days in a year? What is the information that is required to be available only 80% uptime? What information is required to be available up to 95% uptime? What information is required to be available up to 85% uptime? Accordingly, the availability technology controls that are required to be manipulated in a positive one frame varies. Okay, that's what you got to look at it. Fine. Now, confidentiality. Now let's look at confidentiality. How would you be able to understand the technology controls that are required to protect the confidentiality? Objective is what? You need to ensure that information is not slipped into the hands of an unauthorized stakeholder or an unauthorized person. A person could be within your organization or it could be from an outside the organization. So if the goal is to ensure the information which is available only for an authorized stakeholder and there is no breach of confidentiality, how will you go about implementing controls? What are the controls that are possibly available for confidentiality? Number one, access control. There could be multiple access control. Okay, multiple levels of access control are possible. You got physical access control, logical access control, and both sides we'll have to look at it. Okay, because the information that we're talking about, the information could be both physical records as well as electronic records. So access control could be physical access, physical and environmental access control, and the logical access control. That is one mechanism. Today, there are multiple levels of access control have come in, right? It is not just a physical alone. From a logical, you can introduce the multi-layered authentication mechanism where the first layer could be your password. Second layer could be your thumb impression. Third layer could be your retina eye scanning. So when people have to get an access into very sensitive zone, then accordingly the multiple levels of access control can be introduced. More importantly, your organization needs to have a data classification. The data classification standard is such that the organization needs to classify the information into what is sensitive, what is confidential, what is public. Sensitive information needs a very different kind of a treatment. The confidential information needs a very different kind of a treatment. The public information perhaps does not require any kind of a treatment. So you don't need to invest any technology control for information which is going to go public. Accordingly, this is where I was saying the information security is like a medicine. You got to decide what information is confidential, and the information, once you classify it, it is confidential. It has to be stamped at the point of origination. Okay, only then wherever the information travel, the information which is stamped as confidential can be given the appropriate treatment. Okay, encryption. Encryption also helps you to ensure the confidentiality is protected. Encryption is the plain text is converted into a cybertext, which is not readable by normal person. Okay. Steganography is other technology control. Steganography is a kind of an encryption, but in modern days it is not used. Olden days it was used. Steganography is a mechanism by which you would use a chemical ink to write a particular an information on a piece of paper, and the piece of paper in which the information written using a chemical ink is not visible to everyone. When you send the communication to the intended recipient, then the recipient, upon receiving information, when the information containing the media is shown onto a sheet, then the information starts appearing. So that's called steganography, which is currently not available. Then the other technology control is called network traffic padding. The network traffic padding is a mechanism in which the gap in the communication, wherever there is a gap in the communication, they are added with certain bits. Okay, so that now somebody who wanted to get into the information will actually get confused. Okay, in order to ensure confidentiality. So these will be padded, to an extent of 62 bytes, 124 bytes. Okay, that's how it gets added. Then training. So these are the technology controls. Training and awareness is continuous. You got to keep telling people, right? Don't give the user credentials which belongs to somebody else. Okay. So most of the breaching happens only because of the organizations don't spend substantial amount of time and money on training people on information security, because the breach happens only because of the social engineering principles. Somebody who becomes very close to you and me, and then nicely talk to you and then get your username and password, and then tamper the information. That's what it happens there. Fine. So that is from a confidentiality perspective. Let's look at from our integrity perspective. Integrity is what? Integrity is the ability to provide information for carrying out corrections, for modifications only to an authorized stakeholder. There are multiple dimensions to it, but I think at this point in time, you don't need to look at so detail what are the three different dimensions. What you need to understand is now what are the technology controls that are available for ensuring the integrity. That we can have restricted access to data objects. So you need to have a role-based access control. Role-based access control. That is one mechanism. Your application need to have an activity logging. This is very important. An application which houses sensitive information, if the application does not have an activity logging, then you will have a serious problem in maintaining the integrity. The encryption at an object and data level would also help you to protect the integrity of the information. Hash total verification. This is one mechanism I'm going to speak to you a little later on the hash. Hash is any length of the information. A plain text, any length, irrespective of the length of the information. When you apply a hash, it converts the length into an equal length of a word which is not readable. It provides you a number. A number converting any length of a normal communication, a text, into a hash result in a equal length of a message with a number that could be communicated to your recipient, and the recipient upon receipt will open, see what is the hash total, perform a hash total on the message received, compare the hash total received from you and hash total estimated by him or her. If both hash totals are same, then the integrity is protected. So that's another mechanism. You can have a rigorous authentication process. As I told you, multiple levels of MFA, multi-factor authentication. You can also have an intrusion detection system or intrusion prevention system. It could be IPS or IDS. That's another technology control. Verification of object integrity across the storage. And you got today technology evolved where the across everywhere data wherever you have stored the data across the life cycle, where there are integrity verifiers available which can tell you between yesterday and today has something changed. So that's another technology mechanism. Okay, the integrity attack, is normally triggered through virus attacks, logic bombs. Logic bombs are the ones which can actually, like a bomb, it bursts at a particular date and time. Okay, to steal the information. Could be malicious modification, system backdoors. These are all system backdoors are normally driven by the administrators, where you open a port and then don't or you forget to close it. The application developers, when they start developing the application for testing, they create so many backdoors for remote testing and then they don't close it. Rajan holes. Okay, so there are multiple attack on integrity. Then we come to availability. So availability, as I told you, it is two different terminologies you got to understand. What is the recovery time objective and what is the recovery point objective? These two parameters can help you to define what are the applications and data which requires the single point of failures to be eliminated, where I'm going to reduce redundancy. So your objective is to keep eliminating single point of failure so that the denial of service attack is completely prevented. So denial of service attack, how can the only mechanism by which denial of service attack can be mitigated is to have an equivalent system kept running somewhere else outside the environment, so that you can disconnect the main source which has been suffered by the denial of service attack, and then the replicated system is made up and running. So that's the whole objective here. So you got to keep building redundancy. Okay, and you got to ensure that reliable backup mechanism, you got strong, reliable backup mechanism, and restoration mechanism is available. Do not ever, never use a free software for reliable backup and restore. And reliability of the storage mechanism, you've already known. I taught you. Where today we've got a linear tape open, which is a magnetic tape, which can actually be reused for a period of even 30 years, where it's very highly reliable. So I think that's how you need to look at it. So the fundamental principle one is the confidentiality, integrity, and availability. That's a principle one. Now the principle two, it's an extension of confidentiality, integrity, availability. The principle two is, I want you to remember this terminology, I 4 times A. This is the second principle of information security. The I refers to identification. What is identification? As I told you, every object or every executable file or every chatbot or every application programming interface or every individual. See, the identification today has to be understood from a very, very different perspective. Gone are the days where the employees have been asked to report only to a physical location, and each person is given a physical device. From the physical device, the person who's connected to the network is allowed to enter into the system after feeding a unique username and a password. But today it is not so. Today people are using a BOD, bring your own devices. They are not part of your local network. More importantly, it is not the only human. You have forgotten, when application is integrated, there are APIs who are going to seek for another application to permit the transaction. It could be chatbots. It could be bring your own devices, right? So it could be executable files from one application to another application which might seek information. So any object, any individual, any API, any chatbots, when they are seeking information, you need to look at whether those entities are having a unique identification. That's number one. Then the first A in the principle refers to authentication. Now, authentication is what? Authentication is the process of validating the unique identity provided by the person or the software system or a chatbot or an executable file or a bring your own devices which is seeking for an information. You validate them not once, Earlier, once the authentication is validated, you don't track them. But today it is not just once. You have got to continuously track the behavior of the person who sought for the information to be available, or the executable file which has sought the information to be available, and its behavior needs to be continuously monitored until the time the session is completely over. So that's the authentication, the first A. What is the authorization? Authorization is the process after the authentication becomes successful. You would provide the access to the entity or the object for fetching the information or for transforming the information. Now you can provide the authorization in multiple means. There are three different means. One is called the discretionary access control. Second is called mandatory access control. Third is called role-based access control. Now, discretionary access control was the older method where the application owner only will decide, or the data owner only will decide who should have what access. The second MAC, mandatory access control, is one which is enforced by the administrators. The typical example is that when the operating system services are hardened by the administrator, the services as an individual user, you will not be able to release any services. Okay, so that is mandatory access control. But today you need to understand what is the role played by the person, or what is the role played by the software application, or what is the role played by the executable file. Accordingly, you got to divide and create a policy on role-based access control, and the entire authorization must happen based on the readback. The third A is called auditing. So this auditing needs to be understood very, very clearly. It is not a physical auditing. This auditing refers to monitoring. What is monitoring? Once you authenticate and provide access to any entity, what is that entity doing? Which means if Dr. Rajan, I have logged into an SAP application for reviewing and approving the purchase orders. So Dr. Rajan is my unique ID. If my unique ID is employee ID 12147, and I've used a password, okay, and I've used a OTP, okay, then Dr. Rajan, my unique ID is to be logged in. Password should not be logged into the log. And what is the date and time at which I've logged in? What are the activities that I'm performing? They're all required to be logged in and must be audited using a simple AI mechanism, right? Which can find out whether am I doing any fraudulence or not. So that's the third A of the I 4 times A second principle. Fourth A becomes accountability. The accountability refers to the human-related component. See, now it has got a sensitivity attached. When an organization is believing me and providing me an information that is required to be used only for business purposes, I've got to be accountable for. So my behavior needs also to be reviewed. So that is the fourth A. Now, these two principles are extremely important for you to understand before even you think of emulating any kind of a technology controls. If these two principles are not understood, right, then it's not possible for you to implement information security controls. These are the two important principles. Even today, it is valid. And without understanding these two information security principles, one cannot design an information security system. All right. So identification, though I've explained to you, but quickly I'll tell you. Identification refers to the unique identity, right? The unique identity could be provided using your username, or swiping a smart card, or waving a proximity device, or speaking a phrase, or positioning your face, hand, finger in front of the camera. So now these identifications could be multi levels. The multi-level identification can be designed for those information which are extremely sensitive alone. That's all. Okay. Now, let's say, for example, if you have got a group mail ID, the same username, then what is compromised? Identity is compromised. So you are not supposed to have a group mail ID, right? Where you will not know who's doing what, where your identity is compromised, which is a breach of identity. Okay. Now authentication. The authentication is what? Validating the uniqueness of a user. Whatever identity is claimed by user is validated. Now there are three different means, as I told you. Now, first principle of authentication is called something you know. You authenticate based on something you know, which is your password or a PIN. Both you will keep it, right? Which is known to you. The second principle is called something you have. Something you have could be the organization can provide you software tokens. The organization could also provide you smart cards, which can have a printed table at the back, and the system can actually invoke you to feed any three numbers or alphabets at random. You can also have a key, which is an encryption key. So that's the second principle for authentication. The third principle is something you are, which is your biometric, your fingerprint, your iris, your voice recognition. But you've got to decide whether you want the authentication to happen only using something you know, or you want a combination of something you know and something you have, or you want a combination of something you know plus something you have and something you are, which is a multi-layered authentication, which needs to be decided based on the type of information. That is where the information classification becomes the first step, right, in your organization before even you start thinking about what kind of a technology controls that are required. Fine. Authorization. Now, authorization predominantly today must happen through role-based access control, which can be fully automated. Now, what is the role played by the person? If the person, if I need to have an access, in the SAP system where I'm a person who only reviews and approves the purchase order, then I can have the organization can have a policy that at my level, the purchase order value up to about 25 lakhs can be assigned to me where I can approve it. So when you assign the activities that are required to be performed by me in the SAP system, I should be only authorized to perform review of the purchase orders, which are values up to 50 lakhs. The purchase order which is generated, and the moment you find that the value is beyond 50 lakhs, it must not be accessible to me, right? So that's called role-based access control, which could be automated today. Fine. Auditing. Auditing is the ability to review activities performed by every user and foresee whether there is a fraudulent activity that has happened. But today, auditing is now happening through multiple technologies. They're all called SIEM, SOAR, and ARCA, agentless monitoring for cloud-based solutions. Okay. Now, how does this work? Security, incident, and event management system. Security orchestration and response system. So they're all one above other. Security, incident, and event management system. How does it already happen? If you look at it, you come from the operating system. Operating system has a log. It generates a log. So you need to preserve operating system logs. If you have an antivirus application generates a log. You have to preserve that. If you have an IPS generates a log. You have to preserve that as well. Now, when you have an application on which if you have, which is installed on a database generates a log. You need to preserve it. The application, every user, when they log in and the activities are getting logged. Now, there is so much. If you look at it in an organization, a very larger organization where you've got about 4,000, 5,000 people who are accessing multiple applications, and there are 4,000 users who uses the endpoint devices as well. How will you go about manually reviewing them? It is impossible. So these, in order to facilitate auditing through an automated mechanism where you can look at technologies like security incidents and event management system, or a little higher version, which is security orchestration and response, which collects the entire logs online and validates the logs, reviews it, and performs certain actions wherever there is an entity which is unnecessarily accessing, it can disconnect as well. So that's how auditing today is required to be managed. This is today has grown to an extent of SOC. which is Security Operations Center. So Security Operations Center is something which is independently responsible to monitor those security logs. Fine. Accountability. Accountability can be something which is linked to a human activities performed, right? So where a lot of training and education is required in order to ensure accountability is kept intact. One way by which you can look at accountability is a multi-factor authentication, which could, in spite of all multi-factor authentication being available, accountability is something just to come from within a person. So it can actually happen only through a lot of dialogue and a lot more trainings on the basics that are required to be understood by every individual and to be compliant with. So this is the first fundamental principle. Okay. Then the second fundamental principle is the second phase is called data protection mechanism. Now, what are the various philosophies that are available for protecting the data? This is at the highest level. Now, a data protection mechanism could be categorized into 4 different layers. Or phases. The first phase is you got to look at layering. The layering is called defense in depth. The principle is called defense in depth. That's the first principle that you got to look at to design an information security. The second layer is called abstraction. Now, abstraction is more from the perspective of the ease of managing. When I say ease of managing is, let's say you wanted to introduce an access control mechanism. Now, those people, let's say now you've got HR is one group of people. Finance is another group of people. Delivery is the third group of people. Developers is the fourth group of people. So it is abstraction is the ability to combine users under a specific category based on the common parameters upon which the access control mechanism could be developed. So that's the second principle. The third principle is data hiding. So data hiding must actually happen from the software development lifecycle, SDLC. Now, the software engineering principles must be used in detail, even at the point of the development happens. Now, data hiding. Let's say now there is a development which happens, and you use object. It's an object-oriented programming. So in an object-oriented programming, what happens? You're going to develop objects. Okay. Now, a person who has been given the task of designing a particular module. Let's say now this module in an application is that it's a HR module in which first the employees need to create the employee master. Okay, individual employee master. Know your employees. So that has been assigned to a developer. Now, the moment you call it as an object-oriented programming, then for the employee master, how many objects are required? That person understands from the software architecture, and that person is going to design the objects. When you design an object, you got to ensure that the object must be made, every object must be made self-sufficient. What does it mean? Let's say you are going to receive an employee name and you're going to store it inside the object. Then you're going to validate the employee name is a minimum of so many characters. Does not have the special characters. So validation must also happen within the same object. When you're going to store the employee name, the employee ID, date of birth inside the object, then you must ensure that the sensitive information, today it is personally identifiable information, must be protected. So they are all hidden, encrypted here within the object itself, and this object does not exchange this information with object 2. Okay, that's called data hiding. It must happen at the development stage itself. Then the fourth component is called encryption. Encryption can be invoked only for those sensitive information and information which is identified as personally identifiable information, patient health information, and sensitive information like client names, the credit card information, okay, your Aadhaar information, your PAN information. So those sensitive information could be only encrypted. Not every information is required to be encrypted. All right. Okay, so that's what now is talking about. The moment first you say layering, you must ensure there are multiple layers. Now, what are the multiple layers? From the person you, right, until the time the final information is sought. How do you go about building them into building your entire network into multiple layers? Now, let's look at the first thing. Okay. I'll introduce an empty slide here. Okay. So what is the layered architecture? So the layered architecture is something which you are going to build your entire network into multiple layers so that anyone who is seeking information has to come through multiple layers. So that now you are protecting the confidentiality of the information and integrity of the information at various layers. Let's say now there is an ISP provider who provides you an internet connection. The rule one in network design is that an internet connection must always be terminated onto a router. What is the job of a router? A router will only route the packets. So this is layer one. Once the internet is connected with the router, then the router must be linked with the firewall. This is your firewall. This is your second layer. Once the firewall is connected, then from the firewall, anybody who comes in, what is that you will have? You will have the domain server. So where domain server will authenticate. Now you can also have multiple levels here because you can have a proxy server. Instead of domain server coming in here, you can have a proxy server. Instead of directly hitting onto any server directly, a proxy server can help you to bring down the threat proposition which could materialize your vulnerability. Fine. You can also have something called a DHCP server. A DHCP server is one in which every IP address assigned to you or dynamically it is going to assign you an IP address against a person who has been authorized. Okay, fine. You can also have, right? These are all multiple layers only, right? These are multiple layers. You can have a domain server, you can have a DHCP server, you can have a proxy server, right? You can have a monitoring server. Now, let's say there is an application which is required to be accessed by many people who are going to come from an outside to inside. So server is a separate domain by itself. All servers are into a very separate domain. Then you can design the individual user group separately. Your server group and user group should not be sitting in the same LAN. So that's where you are furthermore segregating. It could be a layer 3. This could be a layer 4. Okay. Now, anyone or a particular information or an application is going to be accessed by many people from outside to inside, then do not put them into your server network. Under the firewall, right, you got a specific mechanism where you can attach the server so that the person who comes from an outside comes to the firewall, gets authenticated, uses the application layer and goes out. So you're not permitting that person to come inside. So firewall has got the capability to post any application which is frequently accessed by the user from an outside. All right. So abstraction, as I told you, it's a grouping. Data hiding is a mechanism which is required to be followed at the time of the software development itself. Once the software is developed without a logging mechanism for a complex software, the software cannot be used anymore. Encryption, there are multiple levels of encryption. Okay, you will have a symmetric encryption, asymmetric encryption, elliptic curve. Okay, now I'll tell you what is symmetric, asymmetric, and elliptic curve. If you study network security, this all will be discussed in detail because I myself for now has been teaching network security for various batches. Now, symmetric encryption, I'll tell you what is an encryption is. Now, you want to send a message, or come tomorrow at 9 a.m. You're sending a message to, or your customer is sending a message to you that come and meet me at 9 o'clock tomorrow. This is a plain text, right? What is an encryption? This plain text is converted into unreadable cipher text. That's called a cipher text. Now, in order to convert a plain text into ciphertext, you need a key, an encryption key. The encryption key always generated as a pair of key. Pair 1 could be A, A1. Pair 2 could be B, B1. Pair 3 could be C, C1, just for your understanding. Now, when the plain text is converted into ciphertext using a key, and the same key is used for reversal of the technique from ciphertext to plain text, then that's called a symmetric encryption. Symmetric means same. Same key is used both for encryption and decryption. Asymmetric encryption means different keys are used. One key for encryption, other key for decryption, but that is from the same pair. Now, a pair of key A, A1. Key A will be used for encryption. Key B will be used for decryption. So that is where symmetric and asymmetric encryption would be used. Now, asymmetric encryption is a much stronger than symmetric encryption because symmetric encryption uses the same key. When the key which is used for encryption by inadvertently made available to somebody who's not a part of the network, then using the same key, the person can decrypt and still steal the information. On the contrary, asymmetric encryption is one where there is one key used for encryption and there is a secret key which is used for decryption. The secret key will be always be available with the recipient, and so you will ensure that the information confidentiality is also protected, information integrity is also protected. Right. The elliptic curve cryptography is another mechanism which is slightly advanced. What happens is here the exchange of key happens at a very, very faster rate. Okay, it's the key exchange happens at a faster rate. Both it uses the asymmetric encryption, but the key exchange mechanism will be very quick. Not only that, it also uses a mechanism called hashing. Hashing is irreversible, which means a message which is stamped as hashed will not be reversible. From a message is hashed, what does it mean? A plain text is converted into ciphertext, but the reversible is not possible. So from a ciphertext, you will not be able to convert back by any other person, right, into a plain text. That's a hashing mechanism. Now, what is non-repudiation? Non-repudiation is the denial of denial by the person on a later date that the message is not sent by the person. And so, for example, the HR, you received a message from HR saying that you have been promoted and your salary has been increased from X lakhs to Y lakhs. And end of the month, let's say the appointment order reads that from December 1st, 2022 onwards, the increment will get affected in your salary. At the end of the December, so January, first week of 2023, you go back to the HR and you claim that, see, now I've received a appointment order and now my salary must have been revised from December 1st onwards, but I don't see that it is getting reflected in my January salary. So the HR person says, "Arey Baba, I have not sent you. We have not sent to anybody." So that's called non-repudiation. Non-repudiation is that the claim by the sender that the information has not been sent by me. So how would you go about ensuring that the non-repudiation is controlled through technology? This can be controlled through digital certificates. So digital certificates is the technology through which the non-repudiation mechanism can be controlled. Okay. And the domain server can also be protected if it's a mailing mechanism, or if it is the application which exchanges through a browser, both at a browser level, at a server level, you can have something called SSL, Secure Socket Layer, which exchanges the digital certificate through which non-repudiation. Tomorrow, the sender cannot come back and claim that message has not been sent by me. All right. Now, hashing algorithm, how it works? A sender hashing is a mechanism. What it does is, irrespective of the length of message, irrespective of the length of the message, it could be a message which is, or an image, which could be 1 MB or 200 KB or 5 MB or 1 terabyte, irrespective of the length of the message. When you apply a hashing, the sender calculates a hash code. The hash code, irrespective of the length, will be having the same length. It could be a 13 digit or it could be 11 digit length of a message which carries a number as well, hash code as well. Now, this hashed message with a constant length and a number, the number is generated based on the information that you are sending it. That will be sent through any channel. The recipient, upon receiving the information with the hashed message, first the recipient will unlock the hashed message, then unlock the actual message. On the actual message, the recipient will also perform a hashing, calculate the hash code, compare the calculated hash code with the received hash code. If the calculated hash code is equivalent to the recipient estimated hash code, then the information is intact. Nobody in between has tampered the message. So hashing is an algorithm which could be used to ensure the confidential information is completely protected for its integrity. Okay, fine. So what we do is now, this is the part 1 of the entire information security. I would actually stop at this stage and then we would take a quick quiz.